All right, let's factor everything and see what we can cancel. From the top here, I got 35, 12, and 32. I don't think there's anything I can take out of all those terms. So I'm going to have to use the AC method on this. From this one, again, 7, 16, and 15, there's nothing in common there. 49, 91, 40, that also can't be reduced. And this one is already factored by itself. It's 5n plus 4. It's a linear term n just as the power of 1. So that's fine there. So this first one, let's look at that. A times C, bring a calculator in here. A times C is 35 times 32. That's 1 or 1120. And we have negative 12. Oh yeah, this is going to be positive and negative here. So it's going to be negative 1120 and positive 12. Okay, two numbers that multiply to give this, add to give this. We can see that this number here is much smaller in comparison. So we know that the two numbers have to be pretty close together. And 35 and 32 are already close together. So we know it's going to be somewhat just a little bit further apart than this because they're only three units apart. 35 and 32 is 3 units apart. So I'm looking for numbers that are just a little bit further apart so that I can get 12 when I subtract them. 35 is 5 times 7, and 32 is 2 to the power of 5, I believe. So what we can do is we can kind of rearrange these factors around to get different numbers instead of doing the actual list. Since this number is so large, doing an actual list in there is going to be kind of tedious. So I like to think of it this way. Let's see. I can get a 6, or I can get an 8 from here. This is the same thing as 4 times 8. This is 2 to the power squared and 2 cubed. So that makes 2 to the 5th. And what I can do is I can kind of rearrange them around. I can move a 4 over here and then a 7 down here. So if I do 5 times 4, I get 20. And 7 times 8, I get 56. This is too far apart, so I did too big of a jump here. So instead, let's change out 8 and 7. So we're going to get 5 times 8 is 40. And 4 times 7 is 28. 4 times 7, just double check my math there. 40 times 28 is 1120. Those are 12 units apart. So 40 and 28 are my numbers. I went negative 12, so it's going to be negative 40 there. Okay, so now I can do the AC method. Let me just make some space here. The AC method on the this quadratic here is going to be 35 n squared, then minus 40 n, plus 28 n, and then minus 32. Okay, from the first two terms, I can take out a 5n, 7n minus 8. I can take out a positive 28 and 42 is 4. It's going to be 7n minus 8. So we're going to get 7n minus 8, 5n plus 4. That's this first one. Okay, the next one, 7 times 15 is, let's see, 70 and 35. It's going to be negative 105. B is 16. 7 and 15 are only, let's see, that's 11, 8 units apart. So we're going to have to find numbers that are further apart. So I think that this one's going to actually end up being just fine to go like 105 is 1 times 105. 2 can't go into there. 3 can though. 3 times 3 can go into 10. 3 times with 1 left over. So 35. That is not 16 units apart. So we're going to have to go a little bit further. 5 can go into there. 5 times 21. And that is 16 units apart. So 5 and 21 are my numbers. I need positive, so this has to be positive and that has to be negative. Okay, so the AC method then is going to be 7n squared minus 5n plus 21n minus 15. Now these I can take out just in n, 7n minus 5. And here I can take out a positive 3, 7n minus 5. Okay, 7n minus 5 and n plus 3 is the factored form of this one. All right, let's do this one now. This one might take a little bit of work because the numbers look kind of large here. Let's get a little bit of space here. Okay, 49 times 40. 49 times 40. $19.60, and we have negative 91. So I'm gonna have to probably do something similar to this first one that I showed. I have to play around with the factors a little bit to try and find these numbers, since 1960 is such a large number. Okay, we need to get negative 91. Let's look at 1960. 1960 is 49 times 40. Those are, of course, only 9 units apart. We need a much larger part than that. Even so, it might actually be easiest to go like 2, because these are only 9 units apart. So if I look at much further apart, so like 2 times what is negative is 1960. Because they're so far apart here, I think I can just do it this way. 1960, 980. That's way too far apart. I can take a 7 out of here. 7 goes into 49, and 49 times 40 is this, so 7 can definitely go into there. I get 280, so I'm still too far apart here. I need numbers that are closer. 8 can go into 40, so I can divide this by 8. I get 245, so that's still too far apart. So I need to find numbers that are closer together a little bit more. Okay, 49, I'm just looking at 49 here, and 40. 49 is 7 times 7. 40 is 8 times 5. I can take a factor of 2 from here and put it with the 7 to make 14. So I can take 14 times, just take 1960 divided by 14. I get 140. This is closer. I'm looking for 91 again, units apart. And right now we're at 126. So much closer. Let's see. If I can take out, if I do another 2 here, so I take another 2 factor out of here and pair it with a 14 to make 28. 1960 divided by 28 is 70. So that's too far apart here. Or no, wait. We're looking for, this is positive and this is negative. So they actually have to add up. So this is actually closer, because when they're adding up, we need to, this gives us 98. That's much closer. So they actually have to both be negative. So get negative 98. This is really close. We're looking for negative 91, so a little bit further. 7 times 5 is 35. And if we divide this by 35, I get 56. So adding that up, let's see. That's going to be 11 and 80. That is negative 91. So negative 35 and negative 56. All right. So let me make a little bit of room here. And let's do the AC method on this. So we're going to have 49 n squared minus 35 n minus 56 n, and then plus 40. Now these two I can take out a 7n. That's going to leave me with 7n minus 5. Take out a negative, and 8 I think can go in both of those. 7n minus 5. So I get 7n minus 5, 7n minus 8. Okay. All right. And I can cancel common factors. You can see I can cancel this and this one and this one, and even these cancel. However, I need to first exclude these denominators. So I have three things that have denominators that can equal 0. So from this one, 7n minus 5 equals 0. I add 5 divided by 7 when n equals 5/7. 7n minus 8 equals 0. Add 8 divided by 7 when n equals 8/7. And 5n plus 4 equals 0 when subtract 4 divided by 5, negative 4/5. So n cannot equal these because we cannot have 0 in the denominator. With that being done, I can cancel out 7n minus 5, 7n minus 5, 7n minus 8, 7n minus 8, and 5n plus 4. I'm left with n plus 3. So n plus 3, where n cannot equal 5/7, 8/7, and negative 4/5. That's my full solution.